Hey everyone, so this is going to be the first unit for AP Physics, which is the unit of kinematics. Kinematics is just a fancy way of saying motion. So we're going to talk about objects moving, how they move, different reasons why they move, all that good stuff. And in the beginning, we're going to actually talk about the basic part. That's what this lesson's about. Uh, Describing if an object moves and how it moves. There are two different ways that physicists will actually explain how an object moves. The first one is using the term distance. The distance is the total length that is of the path that's traveled by a person or an object. This takes into account any sort of back turns that it does, any loops, any if it goes left and then goes right. It includes all that. A perfect example of measuring the distance of an object would be, I guess you could say, it would be similar to when you run on a treadmill. The treadmill is running, and it will tell you how far you've ran, even though technically you haven't really moved at all. Or when you check your step meter on a phone, or if you have a smartwatch or a fitness watch, they'll include how many steps you've taken and can calculate how much distance you've traveled. It doesn't take into account whether or not you've traveled left or right, up or down, and where you've actually landed. It just is an overall measurement of how far you've moved. On the flip side, we have another term called displacement. Now, displacement, the definition for that is that it's a straight line distance and direction between your starting position and your ending position. So you're really only talking about how far apart those 2 points are. You can almost imagine that this is essentially just taking a snapshot when the object first begins to move and then when it ends up moving at the end or where it moves, and just comparing those two positions. Down here, there's two images that really show the difference between distance and displacement. With distance, it includes all this backtracking. So the person goes to the left and then goes to the right. It's including all of that. However, the displacement is only from start to finish. The fact that the finish line is really close to where you start, that's all that really matters for displacement. It's important to understand the difference because some equations will use distance, some equations use displacement, and you need to know which one you get to use. Now, each one serves its own purpose. There are a bunch of different reasons why we might pick displacement over distance and vice versa, and that's something you're going to learn as you go through some of these problems. All right. Now, what is one of the, so here, this is just kind of giving that example again. Some differences between the distance and displacement. Like I said, distance only gives you a length. It doesn't really discriminate what direction you go. It doesn't care if you go in circles. It's just tallying it up over and over again. Basically, a really easy example is if you ran on the track, running on the track, if you did 8 full laps, that's equivalent to 2 full miles. But with displacement, it actually does care what direction you go, whether you go up, down, left, or right, and how far you go. So in that same example, if you ran on a track for 8 laps, you would technically have zero displacement because you'd end in the same spot that you start with. So distance doesn't care about direction. It's just an overall number. Displacement does care about direction. It does matter whether you've gone left or right a certain distance. Now, one thing I didn't include in here is that displacement usually does also include a direction as well. So with distance, you would just say what the distance traveled, what the value was of the object. It traveled 5 miles, traveled 10 miles. With displacement, you would include in a final direction in that statement. You would say you were displaced 5 miles east or 10 miles west. And that gives you a good example of where the object actually lays. Um, Now, one thing to also keep in mind is that both objects kind of are measured in the same, I mean, they're both measurements of how far an object has moved. So they're both measured in meters. And they're also both represented by the symbol X or D, depending on whether we're dealing with the AP physics equations or the Regents equations. So just keep that in mind. You might also see delta X and delta D. Again, it's all kind of the same thing. And that's it. That's all it is for determining how far an object moves. All right. If you have any questions, feel free to let me know. Otherwise, good luck and have a great day.